All right, this is a video for the new 4th edition of the Physical Science PACE number 1111. Okay, we're going to look at pages 46 through 49, and just before we do that, I want to do a quick review with you and show you a little shortcut that I tell my students to help them remember which law is which, because it does show up on the self-test and the PACE test, okay? So you have already, by this point, talked about Boyle's law, and you've solved problems with this formula. And you have learned about Charles' law and solved problems with this formula, and the Gay-Lussac law with this formula. But sometimes it's easy to get them confused. So here is a shortcut. Notice with Boyle's law, what is being held constant, what is not changing. And the thing that's missing is the temperature. Okay, so I'm going to draw a line through the temperature. And then for Charles's law, it is the pressure that's missing. And the Gay-Lussac's law is volume. Okay? And when I think of the last name Boyle, but I also think of the other term that I use a lot, and that's boiling water, like to make coffee. Or when I make iced tea, I put water in the kettle and boil the water, and of course I associate that then with temperature. Okay, so boiling I associate with temperature. So the temperature is a thing held constant. Get it? Okay. Charles, now I grew up enjoying Charlie Brown and Linus and Snoopy and Lucy. Remember? They were always picking on poor Charlie Brown. And Lucy especially, if you remember the cartoon at all, she had a football and she would pull it away from him just as he went to kick it, and he would bang his head against a tree and say, "Good grief." So Charlie Brown is always under pressure from everybody around him. Okay, lots of pressure in his life. So I associate pressure with Charlie Brown, Charles, and that's what's held constant. And then that leaves us with the last one, which is volume for the Gay-Lussac's law. All right? So that'll help you. And that leads us to then the combined gas law. And really, if you think of, you don't even have to memorize all of these, all right? Because if you just memorize this one formula here, and then you say, well, I need to remember what Charles's law is. Well, let's see. Charles was under pressure, so I'm going to take off the P, and boom, you're left with V over T, which is Charles's law. Okay? So just memorize this one. Don't spend a lot of time trying to remember the formula for these others. In the combined gas law, here's another way to remember this. Pretend like this T that's on the bottom, this is like the line that the things on the top are resting on, okay? That's like the platform that's being lifted up, and it's holding on this pillar. The T is the pillar holding the pressure and the volume up on top of the T platform. Does that help to visualize it? I think it helps a little bit. Okay, just trying to help you memorize it. All right, so now let's talk about another very important point that I don't think the PACE makes super clear, but as a math teacher, if you've been doing my math videos all along, you know this, and that is that anytime we have a fraction, like let's say 2/5 and 6/15, if they are equal, then this times this, we call them the cross products. If I multiply 2 times 15, I get 30, and if I multiply 5 times 6, I also get 30. So if two quantities are equal, the cross products are equal. So right off the bat, we're just going to take this formula here and multiply P1 times V1 times T2. So this corner times this corner equals, and I'm going to take this corner, T1 times P2 times V2. And obviously, when we're multiplying, it doesn't matter what order you do them in. We call that the commutative property of multiplication. So I could do the P2, V2, T1, doesn't matter. The point is I'm multiplying this times this. All right, now if I need to solve for any one of these letters, I can just divide by the other two letters on that side. So we're actually going to do a problem here. I made up some numbers here. 128 kilopascals, 6 liters, 155 degrees Celsius. This is the starting conditions. And then a change takes place. We're going to add some heat, change the temperature, okay? And the pressure is going to drop a little bit and the volume is going to increase, and we want to know what temperature do I need to bring it to get it to this condition. All right, so we have 5 of the 6 variables. We need to solve for the last one. And notice what I'm solving for, T2. So I'm going to circle T2 and say I want to keep that one all by itself on the left-hand side. So that means I need to divide by P1 and V1, because P1 divided by V1 will cancel. V1 divided by V1, P1 divided by P1 will cancel. But now I have to also divide the other side by the same thing. All right, you've been doing this in Algebra 1. You know this, all right? Whatever you divide on one side, you do the same thing to the other. But now I have a formula. T2 equals T1 times P2 times V2 over V1 and P1. So I don't have any variables repeated. All 5 of the pieces of info should be there. All right. Now, do you remember what we have to do with the temperature? Before we can solve the problem, I'm going to bring out my calculator here. We're going to plug in the 155, not 1,000, Mr. Anger, 155, and we add 273. Okay? So we actually have a temperature of 428 degrees Kelvin. Technically, we don't say degrees Kelvin. We have degrees Celsius and degrees Fahrenheit, but in Kelvin, it's just Kelvin. 428 Kelvin. All right. So now I can solve by plugging in these numbers. Okay? So the first temperature is 428. The second pressure is 101.3. The second volume is 9.00. And we're going to divide by the initial pressure, 128, and the initial volume, which is 6. Now, one other thing I want to point out to you. A lot of students make this mistake. They multiply 428 times 101.3 times 9, and then they say divided by 128, and then they say times the 6, and you're going to get the wrong answer every time. That's because the calculator thinks that you're only dividing by the 128, and then the answer to that is being multiplied times 6. So the best way to make sure you get this right is just multiply the top all together. So 428 times 101.3 times 9. And then write down that big number, 390,207.6. And then I'm going to multiply 128 times 6 and get 768. All right, now I'll go back and take that big number and divide by 768. And I get 508. Okay, so that is the temperature, but it's in Kelvin. And so now I can subtract 273 and get 235. But now let's talk about how many significant figures can we have in our answer. We have 3 here, 4 here, 3 here, 3 here, 3 here. So we can have 3 in our answer. So I think we're safe with 235 because that is 3 significant figures. On the calculator it was actually 235.0828125. But yeah, we can drop everything, just keep the 3 significant figures. All right, so hopefully that makes sense. Remember, just memorize this one formula. Always cross multiply as your first step. And then whatever variable you're solving for, circle that one, divide by the other 2 on both sides, and now once you've listed the information they've given you, plug it in. You don't have to worry about all the units, all right? They're going to give it to you, other than temperature, everything should be in uniform units. So your answer then will come out in the correct units. So you can just do the math. All right, I'm going to do another video about the ideal gas law, which is the next section in your PACE.